Okay, this is our lecture for topic 1, an introduction to statistics. So let's go ahead and hop over to those slides. So with all of our slides, any slides that I'm using here in our lectures are available to you on Canvas under their name here. So they look like this. You have a PDF version of these. So to kick things off, right, the first thing we're going to talk about is just what statistics are, all right? You've maybe heard the term statistics, but statistics are something specific, and we're going to learn slowly, gradually, really what they are, what they mean, and what they do. And what I also like to say is what their limitations are, right? I think some people have the idea that statistics can answer all of our questions, solve all of our problems, and they can help us do that, but they are limited, all right? So let's talk about what statistics are. What are they? All right, statistics are numbers used to describe data from a sample. All right, numbers used to describe data from a sample. Okay, those are statistics. So we have a term in there, a sample. All right, what is a sample? Before we can talk about what a sample is, we need to talk about what a population is. A population is every example or member of a group that you are interested in making a statement about. So what does that mean? In psychology, that often means a group of people that we're interested in making a statement about. Let's say that we're interested in making a statement about the discrepancy in mental health disorders between men and women. All right, then our population would be all men and women, right? Every example or member of a group that we're interested in making a statement about. Now, a sample would be a selection of some of the members of the group that you're interested in making a statement about. All right, so this is the first kind of a powerful piece of statistics, right? We're using samples or subsets of individuals of data to try and make statements about them. All right, so we're going to break into here two different branches of statistics, but let's take a look here, just a little bit of a visual of this, all right? So we have an entire group of individuals, right, or a population that we're interested in making a statement about. And what we have to work with is a sample of those people. So this example here is with means, which of course we haven't even got to yet, but you might have an idea of what a mean or an average is, right? So we can take a sample of individuals, make some statement about them, and then we might think, right, that that statement we've made about the sample can be inferred back to the population in some way, that that sample is somehow representative or reflective of the entire group. So let me point out one more thing on the previous slide here. You'll notice a capital N next to population and a lowercase n next to sample. We won't be doing any math with these values for a little bit, right? But we should start to get familiar with how we symbolize these things in statistics, all right? So we have a big N and a little n here. And you'll notice that we have some different symbols down there at the bottom. We have what's called a mu. Here underneath the population, a mu is a population mean versus an x bar, which is the sample mean. So notice that the x bar says statistic. We get statistics from samples, all right? That's what statistics are. If we know what's true about the entire population, we would have what we call a parameter. And if we have a parameter for a population, then we might not be interested in getting a sample from that population to begin with. So this is the basic mechanism of statistics, that we're pulling small groups from large groups, making a statement about them, and then making an inference back to that larger group. All right, so statistics is a relatively broad term. They're numbers that we use to describe data. And there are two different branches of this that we need to consider. We can simply describe data, or we can make inferences. So we have two major branches of statistics here. Two major branches of statistics. Let me get my head out of the way a little bit so you can read everything that's on here. All right, two branches of statistics. We have descriptive statistics, which are as they sound. They're used to summarize and describe a group of numbers from a research study. The first few topics that we cover in this class are all related to descriptive statistics. All right, so describing data. And then we have inferential statistics, used to draw conclusions and make inferences that are based on the numbers from a research study. Inferential statistics also rely on probability, but we'll get to that a bit later. So we can simply describe how data looks, right? We can describe what's going on in a data set, or we can make inferences or conclusions based on data, which is a bit more complicated. So we'll learn more about this distinction as we go, but it's helpful to have them in mind. So then why do we do statistics? What is the point, right? Why do we bother? We bother because statistics can help us to answer empirical questions. We'll talk a bit more about this in research design. We talk about the scientific method, but statistics can help us to answer questions, right? To answer empirical questions. Empirical is another word for, say, scientific, all right? So statistics can help us to answer scientific questions. What are scientific questions that we have that are related to psychology? If we start to think, we can probably think of quite a few, right? Let's think of some big ones. Maybe why do we dream, right? Or what causes depression? We have a limited understanding of these things, but we certainly don't have answers. And the only way that we'll get to answers or better explanations is through a scientific process. So statistics help us to do this. And I keep saying, right, I feel like I'm underselling statistics a little bit. They're limited and they take a long time to kind of gain enough support for ideas that we really believe in them, right? We'll start to focus in on our vocabulary in this class. We really never prove anything or suggest that anything is true. We just have evidence, right? We can test different ideas and then garner evidence for them. So that's what we're working with here. All right, so let's launch into a couple of just little scenarios. I like to run through these just to get our wheels turning a little bit about empirical questions. So we're going to flush this out a little bit more when we get to research design and we talk about things like hypotheses or predictions. But for now, I'd like to just present some questions, all right, some questions that we actually have some statistical evidence for. So I'll run through these and let us just think about them a bit. So here's our first example. Again, I got to get my big head out of here. Attractiveness of a defendant. All right, attractiveness of a defendant. So I'll go ahead and read this. So to determine the possible effects of attractiveness of a defendant in a jury trial, a legal psychologist, did we know that's a thing? A legal psychologist? Pretty cool job. Asked research participants to read court transcripts from a trial and then give their verdict regarding the defendant, all right? So we have 100 participants shown of the defendant made up to look attractive, while another 100 participants were shown a photo of the same defendant made up to look unattractive. So what do we have here? We have a sample of 200 people, all right, that's why we have our n equals 200. We have 200 people, two groups of 100, each being shown something different. They're being shown the same court transcripts, but attached to a photo of a defendant, one piece made up to look attractive, the other one made up to look unattractive. The question here is, will attractiveness influence the decision made, right, about the defendant? So take just a minute to think about, right, what we're really doing here is the early stages of making a hypothesis, right? What would you predict here? Do you think that attractiveness will have any effect? And let's go ahead and take a look here. Here's our results, okay, and I'll say my piece here. This is limited, right? This is not all of the information at hand, and we're going to become better at looking at statistics, so we'll be able to kind of examine more pieces of evidence. But here's a statistic reported from this particular study. Remember, there's 100 individuals in each sample. So 73 of the participants who saw the unattractive photo gave the verdict of guilty, all right, while only 37 of those who saw the attractive photo gave a guilty verdict. All right, so we see a difference, a divide, based on something as simple as attraction. So, of course, this is a psychology class, though many of you are not going into psychology, but this is what we will start to talk about in the class, is that some psychological variables are difficult to assess, right? Take attraction, for example. We know that attraction exists, right? But how does it influence our behaviors outside of just interpersonal attraction, right? It certainly shouldn't seep its way into the legal system. So there we have it. We might think of this as problematic, and that's something that statistics can help us to unearth here. All right, so let's try another one. All right. Okay, this one's good. This one's on pet ownership. So to determine possible effects of pet ownership on health, a health psychologist, another neat type of psychologist, gave 50 residents of one floor of a retirement home pet cats to take care of, while 50 residents on another floor were not given cats. Researchers counted the number of doctor visits by each of the residents of both groups for a period of 1 year. Okay, another interesting question, right? This is an empirical question. Does owning a pet influence your health? So we could argue that this measure of health isn't exactly perfect, right? There are more measures of health than how many times you go to the doctor in a year. And of course, this is just an excerpt from a longer study about this topic. But what I want you to think about is your gut response to this, right? Based on observations that you've made, do you have a prediction about this? Do you think that pet ownership will sway health in one way or another? Then let's take a look. So results here suggest that non-pet owners made twice as many visits to the doctor during the year as pet owners. All right. Interesting. All right. And I really just use this as an excuse to show you a picture of my dog here. But also to drive home the point that we maybe thought about this or had a prediction about this based on our own experience, right? Maybe you have a cat that you love and you think, yes, of course it contributes to my well-being, right? To my health. But we can use statistics to help support, right, or provide evidence for these hunches that we naturally have based on our experiences in the world. All right, so there's an example. And we have one more that I would like us to consider here. All right, this is another legal one, a little fitting for the time that we're in. But ethics among lawyers, okay, ethics among lawyers. Again, we have some preconceived notions, right? Some ideas based on our observations or our experiences. Some people have a gut reaction to lawyers, right? What are lawyers like, or what do lawyers do? So this is a social psychology study, right? A social psychologist was concerned that law schools were no longer teaching ethics and were more concerned with winning cases, all right? The researchers gave 100 lawyers and 100 non-lawyers a competitiveness rating scale to complete and scored their answers. So we're going to do a comparison between lawyers and non-lawyers in terms of competitiveness. So again, just think, what do you think about this, right? This is an empirical question. What would you predict if we took a look at this here? And let's see. All right, so the competitiveness scale is out of 80. Lawyers average 68 out of 80, while non-lawyers average was 47 out of 80. So again, if you're brand new to statistics and even an average is something unfamiliar to you, that's okay, right? We're going to get there. But the idea here is to just look at differences that we can detect, or at least predict, right, or think about when it comes to research design or research questions. So the conclusion here, based on this particular study, is that lawyers seem to be more competitive than the average folk. But in addition to that, I like to use this example here. I have two funky symbols on this slide. The The one on the right is the scales of justice. We've maybe seen this. It's a common symbol used in legal circles. But on the left, we have a little Greek letter, the Greek letter psi. This is the symbol we use for psychology. So I like to mention this here, that statistics is much like law in that information is innocent until proven guilty. All right, so we'll get into that later when we talk about our hypotheses or predictions. But any thought, any idea, any prediction is innocent until proven guilty, meaning it's innocent until we build up statistical evidence in support of or against it. So we follow a little bit of a similar process here. So I like to kind of point that out nice and early on. So now that we're through with these examples, the question is, why study statistics? What's the point of studying statistics? And it's really to be a critical consumer of information. So I harp on this in the introduction to the class because I think it's so very important, right? To be a critical consumer of information, and statistics can help us do that. So remember, even if you're not going into a research field, a statistics field, or even into psychology, we should be able to be critical of statistics and information that is reported to us. It'll happen throughout your life. It probably happens more than you're even aware of, right? And statistics are a little bit dangerous in that people will trust them at face value, or people don't have the skill set to interpret what statistics really mean. So just for humor's sake, I like to go through a couple of ridiculous statistics, I like to call them. So I'll give you a minute just to read this one, okay? We can have statistics that are true, right, but not necessarily meaningful. Okay, so I think we get the joke here, right? This is technically true. This is a true statement, but is it meaningful? Does it mean anything for our understanding of science or behavior? Not necessarily. So this is again an example using averages. So we will get to averages. We'll get to descriptive statistics in a few topics from now. But again, you've probably read something like this before, right? An average. And do we trust the average that's being reported to us? Sometimes we shouldn't, right? Sometimes it's not appropriate to use such a statistic to describe a certain phenomena. All right, so let's take a look at another. This next one is a correlation. A co-relationship, another word that you've maybe heard. And we don't do correlations until the very end. In fact, it's our last topic, or second to last topic. However, it's used in layman's terms all of the time. People will say there's a correlation between this and this. There's a correlation between this and this, without really understanding what a co-relationship is. That's really what these are co-relationships between variables. So again, we'll get into further depth about the specifics here, but what I want you to focus more on for now is just this graph. This is somewhat of a neat looking graph where it looks like we have two interrelated or co-related variables. If we go ahead and read the title of the graph, we can see what this is talking about. All right, it's comparing two variables about pool drownings, all right, individuals drowning in pools. And it's comparing it to, or correlating it with, the number of films Nicolas Cage appeared in, okay? So you might be thinking that this is nonsense, and you would be absolutely correct. This is nonsense, right? It doesn't make any sense. But if we look at the statistics, right, if we look at the correlation value, you can see it there under the title. This would be what we call a strong correlation and a statistically significant correlation. All right, so in the research context, that's a pretty exciting finding. But a research context relies on some forethought, right? It relies on some specific predictions and basing our ideas based on the past, right? Or based on past science or research. There are plenty of relationships that exist that aren't exactly meaningful. And correlations fall victim to this quite a lot. And we'll talk in the next topic about the limits of correlations, right? We can't say that one of these things caused the other, right? We can't say that Nicolas Cage appearing in more films causes more pool drownings because that's absurd, right? And while this is ridiculous, we'll take a look at more examples throughout the semester which are less ridiculous, right? Which are really meaningful relationships that would be important for us to understand, but that are reported in such a way that we're limited in what we can understand about them. So again, this is for laughs, but also to point out a real problem with a layman's understanding of statistics. So this kind of goes along with that, right? Correlations can't imply a cause. Correlations cannot say that one thing caused another. And this also drives home the point that we're never certain in statistics. There's never any certainty. There's never any proving anything. Never saying that anything is true. There's never accepting anything as the truth. We kind of dance around all of those certainties. And we say what we can within reason, right? We say that we have evidence to suggest one thing, that one hypothesis appears to be true given our sample. And we'll get used to that language, but I like to point that out here. This class is just as much about scientific literacy as it is about being able to perform statistics. And another note on statistics is that data is rich with information, right? If you have a data set, you can likely make a statement about it. But something that I like that's just a little term I really enjoy about statistics is that if you torture data enough, it will confess, all right? You can really make something out of nothing if you have enough data to do so. And that's why it's important for you, for us, for people to be aware of the limits of statistics, right? So we can read statistical findings and determine whether or not we believe that they are, right, valid or important. All right, so that concludes our first lecture. That's our introduction to statistics. Our next topic leads into research design, so I will see you on the next one.